Alright, here is my video guide for lesson 812 day 2. Same kind of ideas, same kind of problems as day 1, but I figured with me being virtual and the difficulty of some of these problems and this concept alone, I figured might as well spend another day practicing it. Use the videos to help you if you're still struggling, but if you feel like you have a good grasp of it from day 1, feel free to try these problems on your own. One thing I'm going to really highlight in this video is using sine instead of cosine. If you remember yesterday's video, I used a lot of different cosine ones and kind of set up that high to low, and we'll see a little bit different with a sine function here today. And so that's going to be the highlight. It's still the same purpose of understanding how to set these up, sine and cosine, modeling these situations. The ones that I want you to work on today are 820 to 824. The video that I'm going to make is really just going to cover 819 from yesterday because I'm going to set that up using sine, and then I'm going to try to work through 8-22. Again, since these problems take some time, it might be a 2 video. But with, again, a 60-minute class period, hopefully that is okay with all of you. Now, we are going to get started here, like I said, with 819. And again, I'll show the problem. You can pause the video and read it to your group if you're kind of working through it that way. Otherwise, just pause the video, read it, and I'm going to start with part A. Okay? What part A says is it says to write an equation to model a distance the pendulum is from the wall at any time t in seconds. And this is, again, just going to be a sine or cosine function because of the way that this pendulum is moving. And what we have is at t equals 4 seconds, the pendulum is 25 centimeters away from the wall. And that's going to be the first point, because if you remember from yesterday, really using 2 points is how we're going to set this up. And just recall that I'm going to try to do this with a sine curve and not a cosine curve, so there is going to be a little difference, and a small tiny difference of what I was doing yesterday to today. But again, starting with my 2 points, I know that at 4 seconds I am 25 centimeters away from the wall, so that's a point 425. Okay? And then it says 3 seconds later, the pendulum is further from the wall at 83 centimeters away. And so that says 3 seconds after that, well, that's 7 seconds then, and then I am 83 away. Now, I could try to set this up using cosine if I went 3 seconds the other way, and so I had 1 second, I'd be at 83 again, and I could go high to low and create a cosine equation, but instead I'm going to set it up with sine. And remember that sine is kind of, it starts at that midline of a cosine function. And so if I think about a cosine function and I draw, we'll do it quickly here, I drew like 2 full cycles of a cosine function. Sine, and that looks terrible. Let me see if I can draw a better one quick. It's kind of hard to do it quickly. So I want to see if I can balance one out a little bit better. It's not great. But sine really kind of would start, if you would look, like the beginning of a sine curve could go from here to where it would end like right here. And so finding that middle point, and I know it's terrible drawing, but if you find that middle point, you can really see this as a sine wave instead of seeing it so much as a cosine wave. And so I'm going to be using that idea as I continue on here. But remember, I do need to do a period, an amplitude, a horizontal shift, and a vertical shift, just really based off of these 2 points. Let's start with the period of the function. Now, the period of the function is going to be the same as it was when I was setting up a cosine problem. I see that it completes half the cycle in 3 seconds, so the whole cycle is going to be completed in 6 seconds, and so that gives me a period of 6. The amplitude isn't changed either by this being a sine function. The amplitude is, again, where I want to find that midline, okay, and then say how much distance is there. Well, the midline of this one, it would be this 25 plus 83. 25 plus 83. Trying to do some quick math in my head. I believe that's 108. And then 108 divided by 2 should give me 54. And 54 is the midline. Now I'm thinking, okay, what takes me, what's that space between 25 and 54, and what's the space between 54 and 83, because that will give me my amplitude there. And the answer is going to be an amplitude of 29, because 29 less than 54 is 25, or 29 more than 54 is 83. Okay, so I use that midline to figure out my amplitude, because again, amplitude is from what we would consider the midline to the highest point. That's your amplitude, or even from your midline down to your lowest point is your amplitude. Okay. Now I have my period, I have my amplitude. Let's get into the horizontal shift, and then this is the one place that the horizontal shift is a little bit different when you represent a sine function, but it's not too bad, because if I want to figure out or start the sine function, like I said, it's really just the middle ground between these 2 points, and when I say that, it's really the middle ground between the x values here. So I just have to think, what's halfway between 4 and 7? And if I choose that halfway point, that's the horizontal shift of my sine function, okay? And so if I wanted to figure out that halfway point, you could add them up and divide them by 2, or for many of us, we can just see that the halfway point between those two is 5.5. So I'm going to choose that to be my horizontal shift, and if I make that small change, I can represent this with a sine function instead of a cosine function. Now, my vertical shift is the last thing I need, and my vertical shift is represented by the midline, which I found right here. And so my vertical shift in this is 54. I can then set up my equation to be h. I'm going to go below because I write with my big fat fingers on my screen. This is h of t equals, and then it goes amplitude first, so that's 29. And because I did that midpoint between the x values, this is a sine function of, and remember this one too, this is important, this is the b value being 2 pi divided by your period of 6, which many of you will probably say that's the same thing as pi over 3, and it is. T minus my horizontal shift of 5.5 plus my vertical shift at the end of 54. Okay? Now, if I, again, like we did yesterday, plug that into Desmos, and when I plug it in, it's going to be represented by pi over 3, which is the same thing as this. And then that graph is going to help me answer the questions in B and C, much like we saw yesterday. Okay? And so we'll first plug it in, which I've already done. And when I turn it on, you'll see the wave pop up. And that is representing this situation, modeling this situation. Now, the question asks us first, if I go back, oops, sorry, wrong one. If I go back, it says, first figure out how far away from the wall was the pendulum at 8 seconds. Well, in here, that's just replacing the t with an 8, and I would be 68.5, I think, let's see the units in here, 68.5 centimeters away from the wall at that time. So that answers that question. And then the next one is asking us, when is the first time the pendulum is 33 centimeters away from the wall? Well, similar to what I did yesterday too, we're going to set a y value equal to 33, and we're going to look for the first place past the y-axis that happens. The first place that happens, wait, maybe there's one above. Nope. First place that's going to happen is at 3.273 seconds is the first time that we get to be 33 centimeters away from the wall. So that answers that question. Now again, I think when I get back, we'll continue talking about this more, maybe try to graph some of these by hand, but this is the way we're going to do it while I'm virtual for this week. Okay? Let's go on to the next one. I have about 5 minutes left in this video, and I'll create another one. We'll see how far I can get. Ultimately, I think that or I hope that using, the video guides from yesterday and today, that maybe you can try to do some of these problems on your own. So I won't try to overkill you with a bunch of problems. I'll let you try them a little bit independently here and just see how you do. And again, maybe that's just a discussion we can have when I get back, just checking in on some of you guys and seeing how that work is going. But let's go to 820. That's the first one of actually today's stuff, which is 820 to 824. And let's take a look at it. Again, you can read the problem here, and I'll just start with part A. So if you pause it and read it, and then we'll go from there. It says to write an equation to model the height of the reflector above the ground at any time t in seconds. And one thing that's weird about this problem is the way the directions are written. And so it says that a reflector on the bicycle wheel is 15 centimeters above the rim, and the diameter of the wheel is 70 centimeters. At 0.5 seconds, the reflector is at its lowest point, and the lowest point that it's going to be, and we'll put this in here, okay, 0. I'm going to write a little bit smaller because this is a weird problem, is 0.5. We are at its lowest point. And that is going to be, usually it would be at like 0 would be the lowest point, but the reflector is 15 centimeters above that. And so at its lowest point, it's really at 15 centimeters above the ground. Okay. And then it says at 75 or 0.75 seconds later, it's going to return to the same position, meaning it went through one full rotation, and it's going to be back at, so 7.75 seconds later, that puts me at 1.25, excuse me. And then I would be back at that 15 centimeters off the ground. Well, that's nice. That kind of tells me the entire thing, but it doesn't help me see a high point and a low point here. So I need to remember that this is going to be represented by a sinusoidal function, and that this halfway between here, so halfway between when it's repeated again, is when it's going to be at its highest point, because that's the kind of beauty of waves. And so I'm thinking that halfway between these two, okay, I am going to have my middle, or my high point, not my low point. So what that's going to give me is, and you can calculate this yourself, if you add these two up, 0.5 plus 1.25, and then divide it by 2 to find that midpoint there, what we're going to have is a high point at 0.875, comma, and now the high point is kind of weird because it would really be the highest point of the tire is at 70 centimeters. If we think about it, I'll draw another terrible tire in here. The highest point of it is at 70 centimeters right here, but the reflector is 15 centimeters less than that, which would put me at a height of then 55 and not 70. Okay. Now, we could use these 2 points, but there's actually another point because of the difference here. If you think about the difference between the low point and the high point here, it's a difference of 0.375. So that actually happens one time before this too, and that's the one that I'm going to use to write this equation, and then I'm going to write it as a cosine function. The first point is 0.375 less than the 0.5, which puts me at 0.125, comma, and then I'm at the high point again, which is 55. Now I'm going to use this high point going to the low point to set up a cosine function. Start with the amplitude of the function. Sorry, no, we always start with the period of the function. The period of this function is, well, I mean, they kind of gave it away right in the beginning. It's actually 0.75 it takes to repeat, and I'm going to represent that 0.75 by 3/4. Just going to help me write my equation. The amplitude of this function is going to be, well, I like doing it this way. It's what I've kind of become accustomed to, 15 plus 55. That gives me 70. 70 divided by 2 gives me 35. And then 20 more than 35 brings me to 55. 20 less than 35 brings me down to 15. So the amplitude is 20. The horizontal shift is my first high point that I can get, which is the 0.25, shifting it that x distance. And then my vertical shift is going to be actually at my midline, which is 35. I'm going to run out of time in this video. I will start the next video, and in the next one, I'll probably be able to finish this one. I'll do 21, and then I will leave the rest up to you. And again, we will cover this again. I know I'm spending 2 days virtually with it, which is maybe the same as 1 day in person. If you want to give me some feedback on the videos, on how things have been going, just please write me an email. I am interested to know how it's all going.